All right, let's see how this works. Um, hello? Is it working? Oh. Why'd a bar show up? Huh? Okay. All right. Can you hear me? Hello. Yes, sound is on. Good. Okay. So, this is basically how it normally is where you see me at. Let's All right. This should work. If we do this. And then hold up. Hey. All right, so I managed to make it work this way. Basically, it is kind of IRL with. I got a screen that works perfect for this, and I was like, you know what? It actually lines up perfectly. Um, this is honestly really smooth, so it works that way. I even got it where I don't even have to turn off the redeems because it smacks me IRL. I love it. Yes, it's a Raspberry Pi Zero. Also a bunch of this stuff. This was a Kickstarter thing. And it's kind of neat. Uh, this, yeah, I got it to work. I got it to work still. Um, so, what I want to say is this is basically, it's kind of beginner sort of deal. Um, it's not an advanced thing. I know most people probably when they look at robots and stuff, they're like, "Oh, it's really complicated." So I don't want to do anything like massively difficult. But I also want to mention that little window you see. Oop, wrong thing. Uh, this one. Hello. I have it covering the cable because why not? But pretty much that is what gives this the data. That is the programming environment that I can just take stuff, shove it in, and you can sort of see like what the program's gonna be. When I run it live, etc., etc. But I also wanted it because different parts of this board do different things, and I kind of want to show it off. And what I'm going to try to do as well is I want to make it where not only can you see it, but we go over kind of how the things work. Um, it's a little bit haphazard, but I think it's going to be pretty decent. Let me make sure I get the because this is my first time using this board. So using this board from scratch, I kind of want to go over like basically the basics, what it's got. Where is it? Uh-oh. Hold up. There it is. Okay, so just to show kind of what it will do, just a little bit. So one of the programs when started, we're gonna have the RGB color change to green. We're going to have it wait about 500 milliseconds, and then we're going to turn off the RGB. Basically, a simple start-stop program. And as soon as we hit run, you'll see this little thing right here. That's going to turn on and then turn off. So, yep, just like that. It's kind of fairly simple with that one, but we're gonna go over. Actually, you know what? Hold up. I can do that, and then that. That should work. Okay, now you can kind of see what I'm working with. Um, Actually, can you see, or is that really, really stupidly small? I don't know. Uh, I thought it looked good, but now I don't know. Can I do? Whoops. Wrong one. You can see it quite well. Okay, good. Let's see. Oh yeah, wow, that works great. So yes, I do preview stuff over this way. I just realized this works so good in like so many different levels. Cause oh my god, where's chat? There y'all are. Hi. I see. Okay, turns out I was missing some stuff. There you are, chat. Hello. Let me put that on top. Yeah, I seem I forgot that. Oh, right. I went on the BGM anyways. Just a little bit extra stuff in the background. Okay, that should be working now. So yeah, when I look at chat, like normally I look this way, so it is like looking right at y'all. When I'm looking at the programming window, it's going to be this way. So that just works out perfectly when I'm looking at the board. When I'm looking at the actual board, this is unintentionally great. Look, I like when stuff works. It barely ever works correctly, but when it works, it is like, yay, it works. Finally, perfect. Oh, I love it. Anyways, we will start with the first one, which is let's see. The IDE interface. There is like you can do this with Python and stuff. But I already went through the basics and I don't want it to be complicated, so we will use the very basic stuff and we'll make it run. Okay. So I do want to go over kind of what this board is to begin with. Let me real quick undo the programming window. Okay, so this is the board. This is a little Picobricks from Robotistan. This was a Kickstarter sort of deal, and essentially it was something I funded, and I was like, okay, it looks cool. I want to try it out. I want to just have some fun with this because it looks neato. It's honestly a little bit different than I thought. I thought it was going to be more disconnectable, but it technically is. So the way it works is this whole board, real quick, it's literally sitting in a 3D printed thing, but the whole thing is wired through the little external areas. So through here, there's wires that pretty much connect everything. Normally, when you set up all these breakout boards, you have to set it up with cables. Give me a second. Let me get a cable and show y'all. Got a whole extra bag of parts. Hold on a second. Okay, so it would use cables like this, and you pretty much plug one into one end and the other into the other end, and that would hook up everything so that you now have a, you know, thing you can run. However, each of those parts are now hardwired in. You don't need to, at least with this. This is for the start. If you wish to disconnect them, you can. Pretty much it's break, and then now you have an individual board, and the little miniature board can then do things. You just need to wire it up instead of just having it plugged in. So I do kind of want to go over each of the different little bits on it. So we'll start with top left, go down, then go on the right, go down, and then focus on the middle. So top left, it's an OLED screen, OLED. Pretty much it's a text sort of based screen that you can, you know, see text. It'll put little images. It's pretty much a miniature display. This is an RGB LED. So depending on how you program it, it will have different, different colors. Anything from RGB that you can make. This right here, it's a little button and LED indicator. So you can have it where you press it and it does something. Press and hold and it does something. You pretty much know that game, Keep Talking and Nobody Explodes. It's the button. Except you can do things with this one. You can make it do a lot of different things. Instead of just, explode. This is a temperature and humidity, sort of deal. I do not know how to use that yet. So, part of this is me learning. I will be learning with everyone here. I haven't used this before. It's fun. I like dealing with new tech. A relay. I think that's just a switch of sorts. I don't know exactly what's with it. So we'll figure that out when we get to it. Top right. Up here. This is motor drivers. It does both servo and just regular DC motors. And the way you determine which one is via this little thing right here. Yeah, so in its current configuration, it is in DC motor, right? Yeah, it's in DC motor. To get it into servo motor, you basically take it and you pop it over one to make the connection. So you can kind of see it's 3 pins, kind of like on this side over here, but these two on the right side are connected. So that's DC. If the two on the left were connected, it would be a servo motor. Yeah, so and then this part, I don't know what this is yet. We'll find out when it comes to it. Wireless. So this does both. There is extra chips inside of my pack that are for Wi-Fi and for a Bluetooth. When it comes time for eventually, we will get to a robot, an actual robot, a simple one, but it is going to be a robot. And this lets me control it wirelessly. I like it. I've always wanted to build one, like a little tiny one like this. I built a big one. And I built Lego ones, but I haven't built a little one from scratch. So that's going to be a neat little experience. Buzzer. This can do different tones, different timings. So it's pretty much a tiny little speaker. LDR. I like this. It's a light dependent resistor. Pretty much if there is something blocking it, it is one state. If a bright light shines on it, it is a second state. I don't know how well that will work, but we'll see. The bottom one, this is a potentiometer. Pretty much it's a dependent resistor that functions depending on how you turn this little knob. So it can be less that way and then more that way. Actually, does it show? It does not. But I'm just going to assume turn it left is less, turn it right is more. Proto board. You can just set stuff up in here. This is like, hey, do you want to wire stuff together and make it work? That's where you do it. It's a Pi Zero, the little brains of the operation. It's been formatted for Picobricks. So this whole little board right here is set up for use with all of the little breakout things we have right now. Alongside that, in the case that for whatever reason you break off, can you not focus? There we go. Okay. So, in the case that you see how they have LDR? You can take that and wire it directly to there. Pretty much, in the case that you do break off these little individual proto boards, these little individual breakout boards, you can still connect them in. You just have to hook them up to the right one. Let me get this right in the right position, and there we go. So that is an explanation of pretty much what we're going to be working with today. I've not used this before, so I'm just gonna go through the basics, the tutorials and stuff. You're gonna see some programming stuff. You're gonna see some little fun things. And yeah, I just want to enjoy it with everybody. So it's starting with pretty much make a flashing LED. So the way flashing LED, it's going to be using this breakout board right here. Yeah, so it's pretty much saying, hey, if you're running it on the board, no wiring necessary, which I like. But in the case that you are trying to hook it up just from, I think it's this one. This isn't sponsored, by the way. I'm just doing this because I like it. Where is it? The GP6. Okay, yep. So it's the button LED, this one, to that one. And that would be the wiring that you need. It's not really complicated. All right. So what it should look like is we need to get the light to turn on and turn off. So with what we have, got to do when started. So when the item starts, forever. So that means this will loop. Picobricks, set red LED. And we gotta wait a little bit. Actually, wait, let's do it this way. So if we hit run, the LED is just gonna turn on. So now you could see, yeah, it's on. And then if we turn it off, it's off. So on, off, on, off. Neato. But we don't want to be clicking a switch. So it's just a matter of setting in a wait. So inside of the loop. Oh, so yeah, this is basically when running loop. Picobricks set LED. Yes. We'll stop it for a second. Wait 500 milliseconds. And then we'll set red LED. Turn off. And then control. And then wait 5 seconds. So actually, we'll set this to 1000. So the way it's going to work is it's going to turn on for a second, and then it's going to... Yep, there it goes. So now you can kind of see it flashing. Nice and good. It's fairly simple though. Let me zoom this in a little bit. So it's essentially a loop program. I think it was for the Lego robotics. Oh, you can't see my mouse on this. Hold up. Let me see something. It should capture the cursor. Oh, there we go. Okay, so yeah, it's like the Lego robotics from way back, which I like. I like it. It's fun. So it starts. It has a forever loop to start the LED. Wait 500, turn it off, then wait another 1,000, and then repeat. The forever pretty much puts it into a back and forth sort of deal. Not really back and forth, but more start, stop, start, stop, start, stop, start, stop. We don't need to comment on this, but yes, that is how it do. Sup, Xian? I'm actually working with real robotics right now. Everything works properly, and I'm absolutely surprised. I broke into the real world, essentially. Still though, I like it. It's fun. Anyways, we can then stop it. It's still going. Okay. We'll chunk that. Oh, hey, it stopped it. Yay. Probably. But this is real. And I like messing with real things. You get to get my hands in here. I get to mess with stuff. It's great. So, yeah. There is a bunch of little things in it. Yes, I have some flesh. I have flesh and I also have hands and everything. I mean, the fun part is you can even throw stuff at me in the real world. It still works. Weirdly enough. I don't know how I got that to work so well, but it does. And I love it. I don't know why that brings me so much delight. So we're going to keep working with that same item, but it's different. So the control. When we don't have an A or B, so let's see. Picobricks button. Wrong one. Hold up. Where in the world is it? Oh, is this it? Nope. Oh, wait. No, this one. When? Hey, there we go. Okay, so this is the proper one for it. So pretty much this is going to be a when it's on, it's on. When it's off, it's off. So we're going to need 2 of these. Picobricks. Picobricks button. Turn it off. Wait a minute. There's a difference. Something's wrong here. When not. When Picobricks. So we're going to have it where when it's on, it sets the button. Okay. But we need to set it where it's not. I'm missing something. Oh, wait, did that do it? No. Off. Uh-oh. Okay, that is not working right. Something glitched. I'm not understanding this right. Alright. Oh, I know what I need to do. I know what I need to do. I know what I need to do. Okay. I'm stupid. Okay, so when it is... The when is correct. But we need to give it an operator. That's it. When it is not the button. Turn it off. There we go. Okay, I needed an operator. I forgot the operator. So, now if we run it. Seems it's glitching a little bit, but essentially hold it and it's on, and then it's off when you don't press it. I don't know why it's glitching like that, though. That's weird. Let me stop it. Oh, I guess it's because there's two programs going in. Huh. Okay, I'll need to double check on that a little bit. I don't want to screw up later. Still though, this will be a different one that we're about to start. So, we just had one where it turns on, it turns off. We press the button, it turns on. We release it, it turns off. Actually, you know what? Let me run it again, but over here so that it's easier to see. So pretty much, press it, turns on. Release it, it turns off. I don't know why it's flashing, but it shouldn't. Seems like it works, though. It's a chunky button. I hope it's not a faulty button. That would be a shame. So, we're going to have it do something automatically. This may glitch, but we'll see if it works. So, this is going to use the RGB and the LDR. So, both of these, which is kind of fun. So the first thing we're going to do is we're going to have it to where if it is dark, this turns white or a different color. So let's trash this program. Let me just make sure there's nothing in here. Yeah. Okay. So, control. When started, this is going to be a infinite loop. Okay? Let's just make sure that it works though, because output, say 1, 2, 3. All right. Oh, okay. So this may work with the OLED. We'll see. Hold on. So we get the when started forever, a loop to say Picobricks light sensor. Wait, hold up. Wrong one. No, wait. I think that's the right one. All right. And then we should push the start button. Oh, 83. Okay. And then dark. All right, so ambient light is 83. Actually, that's really cool. So, yeah, 83 is the ambient light here. I didn't know that's how that worked. So then, you can kind of see as your hand goes over it, it changes the value. And that's all based on resistors. Oh, you know what? I completely forgot. I said I was going to show off some like how the individual parts worked. Let me get that together for you. Hold on. So far we've used the button and the LED. So button. Let's see. Okay, I think that's it. I just want to make sure that okay, yeah. Let me copy image. Let me add image. Let me cancel that because that's stupid. Can I just do this? Oh shit, that was huge. Okay, anyways. Let me explain a little bit how this button works. So, with a push down, pretty much it is an open item normally. And then when you push down, it bridges the connection. So, if you notice, there's the 1, 2, and the 3, 4. Pretty much, this one linked, this one linked. There's a gap in the middle. So the way this is working with the circuit, it's detecting, hey, there's no connection in here. This stays off. Like, let me pull up the previous one. I'll just make it real quick again, just so that y'all can see what I'm talking about. So, button operators when not Picobricks button set red LED, set red LED to not. Okay, so the way it's detecting is currently it's an open circuit in the middle here. It's not bridged. There's Probably a little bit going through here from the outer edge, which is confusing it. But in general, there's a break here. So currently, it's not detecting the button being connected in the middle. So if you notice on that image where they got the little red line, if it is... Also, that's just an image I read from the internet, but, you know, it's the right thing. But when you press it down, it completes it. It is now for sure current. And it says, okay, you now have the true on this. And it just works. It's basically, hey, there's a gap in the middle that you're bridging. Let me stop this. There we go. Okay, so, yep, that's pretty much it. It's pretty much bridging a gap. Yes, remove it. And then I want to get one for the LDR. And LDR is interesting. There we go. Uh-oh. Yep, remove. Let me... I'll need to pull this over here. Hold on. Let me make this a little bit more useful. What did I just see? Chrome. Alright. Let's get this image in here. And pop. There we go. Okay. So, LDR. Pretty much you have two little nodes at the very edge. Like one at the top here, one at the bottom. And the little stuff in the middle. So, pretty much it's a resistor, so it's ceramic. And as light goes on that little squiggly thing, it changes the resistance of the material, which, yeah, it's the more light, it's a photosensitive material. The more light, the more it move, the more the electrons move. The more the electrons move, the more electricity you have, the less resistance. That's kind of how it works, and it's really a fascinating thing. Also, if you didn't know, the little triangle things, that is a resistance symbol normally. They also use the box one, but most of the time I see it, it's with a squiggle. We can remove that. An RGB LED, I do not actually know how that works. Let's see how that looks. Oh. Okay. Wow, that's complicated. But it makes sense. Let me pull that up. Hold on. Yeah, this is a good way of describing it. So this is how I think this one is wired up. Whoa, that's huge. Hold on. Okay. So basically, it's pretty much the same thing as a normal LED, where an LED has a positive and it has an output. However, due to the fact that it's an RGB, it has 3 outputs. It'll go into the positive section. Well, the way it works is positive to negative, which technically it's just direction. But it goes from plus to the output, and it'll go to one of the three outputs depending on how it's set up. If the gate is engaged, it will not go. If it is not engaged, well, it is basically security gates. Colored security gates. That's the best way to put it. I'm trying to make it as simple as possible, by the way. So there may be some slight inaccuracies. I'm doing my best with this. Yeah. So a high signal. Wait. Connected to the external anode lead to control each color. You need to apply low signal. Basically, there's two versions of these. One where it works the way I said it, and one where it works the opposite. So pretty much, one's with the one I showed is a anode RGB. However, there is also cathode, which is the opposite. This doesn't tell me which it is, so I do not know. But basically, in a cathode, the plus would be a minus, and it would be on the other side. So you would have basically the red triangle, green triangle, and blue triangle pointing towards the minus with the little branch in between. That's the only difference. So yeah, that's how the RGB works. A regular LED is a lot better because a regular LED is just a resistor, basically. Let me pull that up. Where is it? Yeah. It's a lot simpler. Basically, a regular LED is you put power into the anode, it goes to the cathode. That's it. Just one thing. So the RGB has multiple gates that you can set. And that's about it. That's how those work. I just want to give a little bit of a idea while we're going through it so that it's not like, oh, this is just me screwing around. I want to give it like a little bit of context. All right. So, let me get the, I think we had 83. Okay. I got an idea of what we need to do. So, control when started, forever. We're gonna go through it again just to make sure that we get it correct. Output, say Picobricks, backwards light sensor, 0 to 100%. Okay, we can actually do other things. Alright, so it's currently 83. If I put my hand over it, it becomes about 25. So now I'm pretty much going to control this by moving my hand over it. So you see a value of 100 full light, 90 and below when you close it with your hand, and values close to 0 in complete darkness. Let's remove this. And we can take this out of here too. All right. So let's put this here. Control. when we're going to have a switch in here. The switch is going to be operator of something less than something. So when the light sensor, we'll use 3 and 4. This is just a value. So you can set it to whatever, but when you're programming, you can have it to pretty much be a switch. So when something happens within an area, or when A is less than B, and then you do a whole function and it says, ta-da. But we're going to do when the light sensor is less than, we'll put 60. Okay? So when it's less than 60, we're going to set the RGB light to whatever color, but we can set it to, we'll set it to white. Okay? So now we have that one. Now, if we run this, now if I put my hand over it, the RGB should turn on. So there we go. Oh, I need to turn the RGB off. There we go. All right, so when the RGB sensor is less than 60, we'll do that. All right, when it is, so we're going to do pretty much the same thing. Duplicate. But we're going to add in a not operator. So the not operator basically says, take this, but make it no. So when it is not less than 60, turn it off. So now if I ever want to turn on the light, pay attention to this thing over here. If I ever want to turn off the light, all I have to do is, ta-da! And now it's turned on. Now I have light in the darkness. But I don't need it all the time. Or maybe I do. Or not. Come on. Eh. Yeah? I like this. It's so much fun, though. You don't know. It's like making a working light sensor. And you can make it go, like, fast. I love it. It's so much fun. I love this stuff. It's, like, great. I can make my own rave. Oh, wait. I can actually do something interesting with this. So I don't necessarily need to have it turn off. What I can do is I can have it set to a different color. So set LED color, random color. So now it's going to flash a bunch of different colors until I put my hand over it, then it's green, white. Ba. Beep. Ooh, actually, green, white, green, white. It doesn't show up too well. Let me set this to the random. Let me set this to red. There we go. So now it'll be red until I put my hand over it. Then it starts like freaking out. I like this so much. You don't know. It's like, I love doing this. It's so cool. I can make a rave just by turning off the lights. Actually, wait, hold up. Let me see. Go ahead and actually turn off my lights. Hold on. Actually, hold up. Let me, hold up. Let me turn it off. Hold up. I'm having fun, okay? Okay, so, because I gotta talk this way for a second. So, you're gonna see the room turn dark. When it turns dark, it's gonna start raving. Let's go. I love it. Alright, rave's off. And then it turns off. Oh, I love this. Okay, yeah. I love it. I can make my own rave just by turning off my lights. Hold up. Oh, that's great. I need some water. Oh, that's fun. I get to mess with shiny lights. Now this is an interesting one. There's a thermometer for this thing. I don't know how this works. We about to find out. God, I love this code. This is fun. I'm gonna clip that later and put that on. Oh, that's fun. So this is gonna work with the OLED and the temperature. An OLED is much more complicated than I have any right to describe. Yeah. It's a lot. It's basically a bunch of different layers of material that, as stuff goes in, it outputs. I do not know how this works. I wish I could teach you, but I did not go into this part. My stuff, I will go... What I normally go into, at least with what I used to do, didn't involve screens. It involved, like, motor controllers. It involved buzzers, type stuff. It involved potentiometers, buttons. This... Let me make sure it's showing. This... and this... These 4 items are all brand spanking new to me. I know nothing of these. So as we learn them, I'm learning them too. So let's see real quick. This is a DHT11 module. Apparently it can sense the temperature and humidity in the environment and send the data to the microcontroller. That's this thing. So we'll write the code to print the temperature value measured by the temperature and humidity sensor. So as it detects stuff in the environment, it puts that into here. Honestly, that's pretty cool. Not gonna lie. So let us start. When the temperature on the screen rises to above 30 degrees. 30 degrees F? 30 degrees C? Huh. Alright. First, you need to import the... Hold on. I need to... What is image 2? Oh, don't think that's anything. Oh well, goodbye. We'll hide the programming window for a bit because I need to import a library apparently. Add library. Graphics. Oh, there it is. Graphics.ubl. What's turtle? Okay, we'll open this one. I think this is the right one. Okay, yep, it did something. Alright, let me turn it back on. There we go. So this has a bunch of stuff. Wait, I can make an image? Oh, wait, that's cool. Wait. Can I make it do this? Hold up. I want to see it. Control. When started. OLED graphics. Where is it? Make. Wait, please. Picobricks. Where is it? Control. OLED. Draw image. No. Right. Make image. Display needs to be initialized. How do I initialize? Initialize. OLED. This is the 0.96 inch. Make image. Yes. Please. Needs a string. No, I want to make it. Okay, we'll keep this for later. Wait. Hey. Hey. I can make it say its parts. Ah, I like this. This is great. I don't know if you can see it well, but hey, I like this. It's showing up on the screen. Sorry, it's really cool. I love it. This is great. Oh wait, clear. Okay, we'll clear it, and then we will draw a circle. Does it work? It's got a. It does. It does. Uh-oh. Oh, I set the inverse. Oh, that's cool. That's cool. I like this. This is fun. I'm sorry. I'm having fun with this. This is great. Draw image. Draw a rectangle. And then draw a circle. We got a little thing in there. So let's draw a circle at 64 by 32. Radius. We'll do another circle. Radius 20. And now I should have a second one. I'm sorry, it's so cool. This is great. And then if I inverse. Oh dear. We're gonna trash that all though. Let's clear it. Oh wait, I forgot to initialize. Initialize, clear, run. There we go. I want to make that heart. I will leave that there. Okay. Sorry, I got distracted. I was so busy having fun with all those little things. The identification blocks. This is the I2C. Okay. Drag the forever block. Forever. And then OLED right hello. Oop, right there. Alright, we're gonna write in here temperature. So we're gonna have it set where it's going to write temperature. And then give us a value. So this will be our display screen for what's going on in there. Now this should say about whatever 70 degrees is in you know, stuff. Oh, 15 and 10. Hold up. 15. Weird. Okay. So, it will now write temperature at 15 and 10. We also wanted to write something else. From the data category. Okay, so this is using stuff from the data category. So this is new to me. Let's see how it works. So we're also going to write something else. And we're going to convert numbers to text. We need to convert 55 and 30. Okay, so this will put whatever we put in here. So it's pretty much going to do temperature at 15 over 10, and then it's going to do whatever we put in here at 55 and 30. What we're going to put in there is we are putting data in there. We're going to join there. We're going to remove this. And we're going to join from the Picobricks temperature. Where is it? There it is. Temperatures in degrees Celsius. So this is going to convert the temperature to text. Right there. I want to make this. Wait a minute, I might be able to. Could get rid of that. But we also have to write something else. OLED. We will write degrees. And the correct position for this one is 4050. Why is my 5 key not working? Weird. Whoops. 50. There we go. Okay, so this should start. Hey, we're 27 degrees. Does it turn up if I put my hand on it? I don't want to use a hair dryer because that would make it hot. However, let me do something a little bit iffy. So you know what? I'm gonna dust my computer real quick. Hold on. If you're wondering why I'm doing that, it's because this makes the can cold. So that I can take the can and put that on the thing and see how it turns out. And also, it's really good to dust out your PC once in a while. Okay, that's cold. Let's see. Still 27 degrees. I guess we'll have to wait a minute and see if it actually cools down. I mean, it's cold, at the very least. Come on. Won't you go down to 26? Oh, well, it is about 27 degrees in here. I would need to do something really stupid for it to go down further. The problem is I don't want to go against Twitch TOS with accidental damage. You know, Twitch TOS that, you know, you don't really want to go against. Totally not going against Twitch TOS, you know? Totally not. Nothing damaging at all. No possible danger. See? Damn it. Oh, well, it's just 27 degrees in here. Okay, that's how I like it. I guess it's just how it be. Oh well. Oh, wait, no. It did go down. It did cool down. I did cool it down. Haha! 23 degrees. Yeah! I was able to cool it down with that trick. Neato! That's awesome. So it is detecting the actual temperature. And then if we heat it back up. Come on. Oh, it's probably going to take a while. Trying to heat it up with breath. See if that works. Nope, it is just stuck there for a while now. Okay, yeah, we cooled it down a little bit too much. Anyways, that was cool. So a graphic monitor? Oh, okay. So this is pretty much something that we can see. You know, I wonder something. Nope, that didn't work. Oh, wait, I did heat it up. It became 28 degrees. Eh! I like this. This is awesome. It's so much fun. Okay, so this is pretty much a light dimmer via programming. So we're gonna use a potentiometer, and pretty much we're going to increase and decrease it and make this turn on. Yeah. Oh wait, no, this is gonna do something special. What in the heck? Alright. I don't know what we're doing here. Hold up. We're gonna clear the OLED just so that it doesn't burn out. There we go. Okay. So, control. When we're going to what the shit? Okay, this is going on a little bit complicated. Pins. Set pin. To adjust the brightness of the LED, we can send a 3.3 voltage. By dividing it into 1024 parts? To which the GPIO number to which the red LED is connected on the Picobricks. The GPIO number. Oh wait, there it is. I think that should be 7? Yeah, that should be 7 then. So we're going to set pin 7. Hey, Rose. Welcome, welcome. We're doing a bunch of different stuff with this thing. How you doing? Hope you're doing good. I'm real. I'm real and you can still throw stuff at me. We just finished messing with a temperature readout. And now I am working with electronics on this thing. And I'm trying to figure out how the heck it works. Okay, so this is basically a little board of weird, wacky, wonderful things. And I'm just going through the tutorial stuff and figuring out what the heck it is. I gotcha. I did get that to still work. And the lag's normal. Hold up, here's an extra one for you. Ah. The fact it still works is amazing. I love it. Alright. So, show advanced blocks. What is this? What the heck? You'll see ready variables in the variables category. Whoa, that's a lot of stuff. PB pin. Red LED. That's what I want. To the field labeled 1 to represent the pin that the... Oh, okay, that makes it easier. So pretty much we're saying whatever pin the red LED is plugged into, we're going to set that to the potentiometer. There. Drag the graph output. So we're going to do a graph from that. Where the necessary code of the values appear on the graphic monitor. The graphic icon. So apparently this data graph is going to show me some stuff. So let's run it. So then if I do this... Oh, data graph. Oh, whoops. Oh, wait. Oh! 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 Okay. Okay, I know what's going on. Okay, hold up. I did the right thing. I just did it wrong. Beep. Okay, now run. Okay, so now, you see it says 0? And I can go, You can see the little red light turning on and off on the left side. This one right here. It's turning darker and lighter just based on how I move the graph. And you can see on the graph, like, the power I'm giving it. Oh, that's cool. So wait. I can zoom like this. I'm drawing stuff. I don't know why that's so much fun, but then you can see the little red LED like showing like what it does. Oh, that's great. I love it. I'm having fun with this. This is great. All right. We're going to that was the wrong thing to press. Trash that. Okay, and we're going to Picobricks. Control when started. Picobricks. Set LED to off. There we go. Okay, now we've got it back to a neutral state. But still, that was cool. We got to see the potentiometer do some stuff. That's awesome. All right. We will prepare. We're gonna play a song on this thing. We get to make a song on this sucker. I love it. Whose sheet we know. The button LED module to start the song. Okay, so this is going to be okay. So what it's going to use is it's going to use the OLED, the button, the buzzer, and it's going to use a potentiometer. It's going to use all four of these. And pretty much we change the tempo with this. This starts it, and as long as we have it pressed, we have a song. This plays it, and this is going to do something different. That's so cool. I love this. This is great. This right here. I like messing with stuff like this. It's fun. It's fun. It's really fun. It's like really expensive Legos that you get to like just see everything light up and make noises. It's so good. Oh, check the button press. Probably will make the mouse preferred. We'll use a rhythm to increase or decrease playing times and notes. Value 0 to 1 to 2, but the 1 to 3 inside real data structures that we use when we want to use values that can be. Okay, so basically we're gonna be doing a bunch of hokey dokey stuff. I see. Okay, that's what it's gonna do. All right. This is going to take a hot minute to program. So, we're just going to start with our basic control. When started, forever. Pretty much when you start, it will keep going. At the OLED display library. All right, we're going to add in the initialize for the display. There we go. Okay, good. So this basically says when started, start the program. Run it forever, and then we're gonna add a bunch of stuff in here. So we're going to go to variables, and we're gonna add one. We're gonna name it rhythm, because that's how the program takes its variable. Let's see. Where is it? There it is. So now we have rhythm in here. Okay. So forever, we're going to set our rhythm. Excuse me. Oh, there we go. Oh yeah, it's a bit of fancy coding things. Basically, we're going to use a combination of this, this, and this to make music. All four of these. Actually, I want to show... Tell you what, before we do that, I can redo this. I want to show off something fancy. So we're gonna... This was one of the earlier ones, but I like it so much, I'm gonna do it again. We're gonna take our operators when Picobricks set RGB LED color. We're gonna do a random color. This is the rave one from before. So when started, Picobricks light sensor less than 60. Shoot, what was it again? I'm close. Ba-da-ba-da. Oh. Of course, I had the wrong one. This one. When the Picobricks light sensor is less than 60, set the RGB color to a random color. When let's duplicate this. We need also the operator not. When not less than 60, we turn the RGB off. Okay, here we go. So the way this works is because of my room's light, this currently is off. However, once the room's light turns off, due to this programming, this will now change into a bunch of random colors. So 1 second. And did I forget to hit run? Yep. And there we go. And now it lights up. And I can turn it on and it turns off. And now it turns back on again. I like doing that. It's so cool. I can also do it with my hand, but it's more fun when the light's off. You know? Okay. Well, I'm going to be doing some programming for the next part. That was so cool. I like that one. Is this still running? No. Good. Okay. Let me go back down and let me get started on this music one, because I want to see what this does. So this uses the variable rhythm. So control when started. We're going to initialize the OLED. That way we now have a fancy thing on our screen. We're going to set our variable, which is going to be rhythm, to the potentiometer. So as we do the potentiometer, it's going to change. Ooh, wait. We need to do it out of something. So we'll put it in here, divided by 128. All right, so that's gonna. Oh, I forgot the forever. Hold on. Forever. And now you're in the loop. Okay, so this is gonna pretty much let us set our rhythm within 128 because this goes up really high. We're going to write on the OLED screen, and we're gonna join the data. So we're gonna make some extra data become this data. We're going to join speed and rhythm. I know what rhythm actually is, but I believe it needs to be rhythm for this. And we're going to set this to 10 and 35. All right, there we go. I like the comfy one, it's cute. Weird. I may need a new keyboard soon. Apparently my numpad is breaking. I don't know what happened. Oh, I appreciate it. You cute too. All right. It's the 10 plus and 10 field and division blanks. Okay, so I basically did that. Drag the when block from the control for continuous monitoring of the button press status. So when we're going to set it to when we press the button. So when push button. Oh, hold up. I need to add a new library. Add library. Libraries. Tone. Oh, Snowfield, hello. Welcome, welcome. I'm in the middle of making this thing make music. And thank you for the subscription. 17 months, jeez 'em. But hey, how are you doing? Hope you're doing well. I've been up to a whole bunch of shenanigans today, and it's been great. Alright, let me put it back on, and there we go. So, essentially, this is going to have this work, and then we're going to make... Wait, I can do a whole... Oh, jeez, I can do a lot. Oh, send one run. Nice, nice, nice. Oh, yeah, you're going to need coffee for that. Let's see, though. I need the Picobricks. When Picobricks button. This is Picobricks, by the way. It's pretty much a little all-in-one sort of board of electronic fun. It's great. Add block. I'm pretty much learning this as I go along, and it takes a hot minute. Play note C, octave 0, 4. And then we need to put in the operator for 10 over 2 into there. Alright. The rhythm variable takes the lowest value of 0. I'm still learning this though, so it will be a little bit rough. Since 0, a quotient of a number will be infinite, drag the 10 plus 2 sum block to the denominator. So 10 plus 2 sum block to the denominator. Two. Put the rhythm value variable in field 10. So we're going to take this and put it in field... Hold up, where the heck we put this? Oh, shit. Okay. This is complicated. This is very complicated. So, you see how this looks simple right now? We're going to basically take this and copy paste over and over and over again. I'm going to shove this off to the side because that's pretty much good now. But we need this up at the top because that's about to happen a lot. So we need rhythm right there. 1. And then we need 1. Okay. So oh boy, this is complicated. I had an evil idea. Hold up. Hold up. I'm gonna do something, and I'm gonna have y'all. All right. So this is. This is so stupid. Oh god. Let's see. It's gonna take a few notes. Is this? Oh, that's much better. Oh my god. What? Trust me. Y'all gonna see something. I just need to make it work. God, it's really complicated. I know. Look. It's gonna be worth. It's gonna be worth. I just need... I'm trying to read music again. Octave 1. We'll do C, octave 1. Okay. And then we need okay, next one's going to be 500. No, stop. We then need a D at octave 1. For can you hear it? Okay, you can't hear it. Good. I can hear it. Y'all can't. Wait a minute, and I'll make you hear it. Don't worry. It's great. Alright. See, we want... Actually, this needs to be about 250. 250. Let's see. No. No, that's too long. It has pauses. That's the issue. Okay, I think I got that one. Alright, we'll stop it. We're going to copy. Duplicate all. Hey, that's faster. Alright, and then we need to do... We'll do 500. And then we'll do... this needs to be in octave 0. This needs to be in octave 0 as well. This needs to be a... that's B. Oh wait, no, that's still octave 1. Alright, hold up. Let's see. Oh, no, that's too high. Alright, this needs to be about 250. And 250 here. Sorry, I am busy making something stupid. Duplicate. Okay. And then I need one to do A. All right, let's see. How does this work? It's crude, but I got it close. It's really sped up. This needs to be 750. Okay, that should be perfect. That should be perfect right now. Okay. Y'all will see what it is later. Oh, this is stupid. All right. Right now, the default beats for each time in the field of 10 value of 1,000 represents 500 half stroke and 250 represents a quarter. Show the user now playing. Okay. When Picobricks button. All right. We need to write. At 15:15. I'll put what it is later. All right. And then we'll put it in the control to repeat it. Gonna shove this whole thing in here. And then we're going to clear it after. Okay. And we're gonna play it like 2 times. And we're playing. Anyways. Control the pace of the melody. Let's see. Oh. And then this. Oop. Okay. We're gonna stop it real quick. I got it to play C-Bat. Okay. So an issue. My button right here is a little bit bugged. A little bit bugged. So unfortunately that ain't working right. Ooh! But I can fix it because I have potentiometer. So when the operator, when the light sensor is less than we'll do 60, then it'll repeat it twice. So let's see. Let's see if you can hear it. Oh my god, it doesn't play right. My voice is going to be really loud for a second. Hold up. So it's going to be really loud for a second. That's so you can hear this thing go. I can hear it. Let's see if you can hear it. This is a Robot Plays Seabat. Could y'all hear that? I hope so. Did that actually work? Let me boost the speed just a little bit. Okay, hold up. This will be really weird. So apparently it likes my voice. It doesn't like picking up the damn thing. I just wanted to show y'all how it plays Seabat. I don't know how to make this work. Oh wait, maybe if I do this. Maybe? Nope, not it. Oh wait, I think I know what it is. Filters? Aha! Okay. Now let's see. There we go. Okay, that should have gone through. I had to disable all my filters. But yeah. I got a robot to play Seabat. I guess I can make it faster. Hold up. Watch. Oh shit. Stuff fell over. Ah. Oh no. I'm alive. Sort of. Also, I don't know why it's dying. It looks like it's up on my end. So that might be a connection issue on your end, Rose. I think. Oh my god, I made a robot play Seabat though. I am happy. I need to edit that together later. That would be a great highlight. I'm only dropping 2.2% of my frames though. Like, it looks up. I haven't disconnected from Discord. Well, not with the Discord, but like there was normally there's like a Discord thing if oh yeah, then that's absolutely a you getting booted from chat. That's not mine. Oi. Good. But yes, I made a robot play Seabat. I'm happy. I'll definitely get the clip later. But yeah, pretty much depending on how I change this potentiometer, it changes what it sounds like. And then if I cover it up, it plays it twice. And then I can go really slow. I can only do so much because I ain't got the pauses, but I got a robot to play freaking Seabat. I love this. Anyways. Oh, that's stupid. I love it. I'm gonna trash that garbage program. And we're gonna get that. That. We're gonna change the OLED to clear. Run that. There we go. And trash it. Okay. Now, we go on to next one. Damn it, it uses the freaking Okay, so this one is basically a coding to do a game where you press a button and it times your reaction. The problem is this button right here is bugged. It's cheap ass button. So we will pass that one on by. Jeez. That is actually a decent chunk of code. Why does this all use the damn freaking... Okay, so we're going to set this up to use the LDR. Yeah, you know what? We can make this work. If the button isn't working, we can make the button function work with this thing. There's no issue with that. Okay. I got an idea to make it work. How long have I been streaming? 2 hours and 10 minutes, jeez. We'll probably go for 3 hours. Next is a timer. Alarm clock. So I wonder if I could disconnect the button and if it would work better. I don't know. Okay, so we got a definite chunk of stuff to make it work. Two wire sockets and sockets. Oh, okay. After a few more of these, it starts getting into items where Okay. Tell you what. We can have it. We did see that, so we're pretty much good for now. I don't want this to be the only one. We'll probably do 3 or 4 parts of this. But I also want to see about going into maybe some other items and seeing about fixing the button, because the button's needed for a decent chunk of these. So yeah, we will need to do that a little bit later. I need to figure out how to disconnect that one. Once we do, what I will propose doing is basically yeah, you know what? We'll stop raids for a while. We are going to finish up with this for now. I'll need to see about doing something with that button. We'll send a raid somebody's way. Just because we got it. Twitch. Let's see who we got live. But yeah, I need to fix that thing a little bit, so if it ain't working, you know, fix it. Let's see. To raid. Lane? Oh wait, no, Kisa's doing freaking Resident Evil 4. I love that game. We'll raid Kisa. Oh yeah, she just started too. Even better. There we go. I'm stupid. There we go. Wrong slash. Anyways, I do want to thank y'all. Hope y'all enjoyed. I hope that was fun to watch. Yeah. Rose. Excuse me. I was doing an outro. Anyways, yeah, with the I absolutely freaking love this. That was so much fun. I need to figure out what's going on with the button. But anyways, thank y'all for coming out. I hope y'all enjoyed. I will schedule this the next time we do it, so it will be another scheduled stream. As of future streams, I'm working on Minecraft on a server hosted by Orihime. And I believe I have permission to stream on it. If I do, great. Because it's actually a lot of fun. And yeah, we'll do that in the future. Anyways, thank you for watching, and I'll see y'all later. Good night.